All right, calcium carbonate is called calcite, and that is the principal mineral. So what we're trying to do is ignore all the words. We're trying to get from 4.86 moles of calcium carbonate into the mass in grams. Okay, so this isn't really a very difficult problem. We're just trying to go from moles to grams, and we can do that using the molar mass. So when we add up a calcium and a carbon and 3 oxygens, we get 100.9 grams per mole. So we're going to take our 4.86 moles of calcium carbonate. We're going to multiply it by our conversion factor, 100.9 grams in every 1 mole. And our moles are going to cancel. And now we have the mass in grams. So we end up with about 486 grams of calcium carbonate. Okay, so we have 3 sig figs. We end with 3 sig figs. Very important to remember that. All right, so let's do this next one. Get it focused a little bit better. All right, isopentyl acetate. We have C7H14O2. Okay, and it says that we have 1 times 10 to the minus 6 grams. Note the 1 sig fig here. We're trying to get to how many molecules. And then the second part asks us how many atoms of carbon. So we're trying to get from grams into molecules. And then the second part asks us to go all the way to atoms of carbon. Okay, so this isn't very difficult. We're gonna start with 1 times 10 to the minus 6 grams of C7H14O2. We are going to go into moles because we can't go right from grams to molecules. That doesn't work. So we need to use the molar mass to get from grams to moles, which is 130.18 grams per 1 mole. Okay, now we know that there are, in 1 mole, 6.022 times 10 to the 23rd molecules. Okay, so this gives us 4.62 times 10 to the 15th molecules. But remember that we only had 1 sig fig here, just 1. So we have to round this. If we were going to give an answer to how many molecules, we'd have to say 5 times 10 to the 15th molecules. Okay? But it's important to know that this is like a real number. So when we continue with this and we say how many atoms of carbon, we need to not use the 5 because we don't want to round the 1 sig fig and then use that in a calculation. So we're going to start with our same 4.62 times 10 to the 15th molecules. And we know that in 1 molecule of C7H14O2, 1 molecule, there are 7 carbon atoms. So when we multiply this out, we get 3.23 times 10 to the 16th carbon atoms. Okay, so that is really interesting. Now we have to go back to the 1 sig fig. So we have 3 times 10 to the 16th carbon atoms. But what I want you to notice is that if we had started with this 5, we would have got 5 times 7 is 35, and we would have ended up with 3.5 times 10 to the 16th, and then we would have had around that 3.5 to 4. So we would have ended up with 4 times 10 to the 16th instead of 3 times 10 to the 16th, and we would have had a wrong answer. So we can't use the rounded value in a secondary calculation. It's very important to note that.